Question number 2. Determine the convergence or divergence of this series, the sum from n from 2 to infinity of 3n plus 10 over 4n minus 7, all of this raised to the nth power. Okay, so what test to use? The big giveaway is this right here. We are raising some function of n to the nth power, so this really strongly suggests that we should be thinking about the root test. So for the root test, what we're going to do is that we're going to take the nth root of the summand here of a sub n and take the limit of that nth root as n goes to infinity. So let's crunch things out. For the record, here's a statement of the root test. We're taking the limit as n goes to infinity of a sub n, the absolute value of that to the 1 over n power. And based off of whether this limit is less than 1 or greater than 1, we can conclude something about convergence here. Okay, so we're going to look at the nth root of a sub n, and absolute value, I should say here, but everything in sight is positive, so I can drop the absolute value bars. And when we do this, we see why the root test is such a natural choice here. That we end up multiplying these exponents together, and n times 1 over n is 1, and so a sub n to the 1 over n power is just 3n plus 10 divided by 4n minus 7. So now we have to take the limit of this quantity as n goes to infinity. So L is the limit as n goes to infinity of 3n plus 10 divided by 4n minus 7. And it's pretty easy to see that this is 3/4. Use L'Hopital's rule or something like that. And 3/4 is less than 1. So our limit here of the nth root of the terms is strictly less than 1. So we conclude that our series absolutely converges. So pretty straightforward application of the root test. How to know which test to use. The best way to do that is realize when you're raising a function of n to the nth power, you should think about using the root test.